did not expect to have the sun in my face when I did this. So we're going counterclockwise on P1, bringing the offset down. Ooh, it looks like we're going to get close to our 300 there. We exceeded 300. So I'm on P2, and I'm actually going to back it off a little here. I may be premature. Okay, and back to P1. See if we can zero that offset. Oh, going the wrong way. And the question you're probably asking is, do I really need to go get 3 meters? Well, it certainly helps. And you see I've had to dig out my old 30-year-old Radio Shack meter here. Ooh, there's a jump there. Leave it there, see what happens. So we have 296 and 310. So we're pretty much in the ballpark of our initial target of 300 millivolts drop across the source resistors, and we're going to watch that for thermal stability. So far, let's see, 37, 40, 38, and 37. So let's see, what else do I need to tell you? Let's see, here's the amplifier. See the got the blue LEDs on the front. Here's inside. And this is the process. So we'll kind of watch things, and you see we're drifting positive. Looks like, well, it looked like it was increasing slightly on the positive side before. We'll kind of keep an eye on that. Yes, we have a warm heat sink. You might even say it's approaching hot where the devices are. Although right now the heatsink is not, it hasn't heated to a homogeneous temperature all over its surface. There's hot and cold spots on it. So, oh wow, we've gone back down, so we stabilized, and that wants to shut off again. But hopefully this gives you an insight into the biasing process. If it is happy and stable at this point, we're going to give this like half an hour at least at this point. If it's happy and stable, you know, nothing starts taking off for one of the rails, then we'll bring it up to as close to 350 as I can with zero offset. Now I'm not sure if at this point I should have the top cover on or not. One of the reasons I got the front panel on is so that I could mount the top cover. Because it will create a more stable thermal environment inside the amplifier. So now I put the top cover on. I believe they mentioned that. Where do they see? Okay, they in the initial article, he recommends bringing it up to 75% bias with zero offset, and then put the top cover on for thermal equilibrium. Then when it's stable, increase it up to 90% of bias with zero, put the lid back on, and let it cook for a few days. Oh God. I don't know if I want to leave this on for a few days. Probably wouldn't need to run the heater though. That was my initial thought of this. Going with this amp. One, I was curious about Class A. Two, I kept reading so much about Nelson Pass's first watt designs. And three, I said, I'm running all these damn space heaters. Why don't they just heat the house with audio? Build a Class A amp. As you probably know, a Class A amp has the lowest distortion of any power amplifier class. Yeah, I think that still includes Class D. But it is the least efficient, whereas Class D obviously is the most efficient. And a Class A amplifier, for every watt of audio that it produces, it's generating 3 watts of heat. So it's basically 25% efficient. Which is why this will probably be my winter amplifier. So far, oh, okay, yeah, that's a little interesting. The P channels seem warmer than the N channels. But they have less current. That may just be how the heat sink's heating up. I'm not sure. Yeah, we've drifted a bit positive. Yeah, it looks like positive voltage is creeping down. Offset is creeping 4 millivolts positive. Negative voltage has seemed more or less stable. I haven't seen it move too much. It may be increasing slightly here. No, it goes back down. goes off. Jog that. Definitely need to replace the batteries on these again once I'm done. They all have fresh batteries for now. Okay, this is about the fourth, fifth night I've been tweaking the amp in, and it requires a lot of patience, as I've discovered, but I think I'm finally getting it in the ballpark where I want it. So we'll see how it goes here. I gotta raise this up. Okay, and then wrong thing. Come over here. There's our adjustments. So this is what I've been aiming for. Try get a 350 millivolts max, and then adjust the offset to where it's more or less stable around 0. And right now we're 46. Oh, that's hit something else. There we go. 48 seems to be where it's stabilized at. So I think we're doing good here. So let's turn this on. Turn this on. What did that do? That jumped up to... Oh, this reset again. So it's that should be okay. See, we're getting a pretty decent looking sine wave so far. That's it. Wow, 0.5 volt drive. So let's take that down one more. See if we can go up to clipping here. It was almost a volt to drive. This is about to fall asleep, so. But as you can see, we are alive and well. And a few things. I was on the DIY audio website and read through a lot of the material on the amp, and it's best to set it with the source drops across the resistors at maximum 350 millivolts. You don't want to get it up around 400 millivolts, because then the diodes, the switching diodes we're using to short out the same resistors will start to conduct, and you don't want that as a steady state condition. It would affect the amplifier stability. You don't really need to have dummy loads. I do, because I'm doing things like this, but they're only required for dynamic tests when you actually apply a signal to the amp. And apparently any amount of offset less than 50 millivolts is good. As you can see, I'm a bit of a stickler. I've been trying to get it quite low. Pretty happy with how it is looking and how it's behaving. Now that I have this this has drifted a bit. See if it has a signal on it. If I short it again, it should drop back down. I hope. So see if it got very hot. Not really. 46 again. 47. Yeah, it shouldn't change thermally too much. It's Class A. It's always drawing full current. So I think we're there. It's starting to. It'll very slowly creep down. As I've mentioned before, it requires a lot of patience to dial this thing in. You're basically, you turn it on for 4 hours to start. You do your initial tweaks, and then you have to wait 20 minutes before you can check it and tweak it again. And it's just, it seems like an endless number of iterations of that. But I'm happy with the results. Hopefully I'll be able to do some sound tests with it on tomorrow night, and I'll probably be using those poor little speakers over there that came with a Sony compact system I have, just because they're sacrificial, like the Pioneer amp, so if anything should go wrong, I won't be out too much money. I want to make sure this has been playing now for, or been on for 5 nights, so I have a feeling it's going to behave pretty reliably, but you never know when you start applying music signals. So it's good to have play it its first few nights with something that you won't miss should something go wrong. This is Robert. It's Friday night, and I'm still at this. Oops, that fell asleep. Let's see if we can move in here. And this will need to be tweaked. There. So this, I'm at the point now, I've been at this 5, 6 nights. And I think I'm at a pretty much where I want to be bias-wise. So as you can see, I've managed to get the offset pretty damn low. It seems stable at under 2 millivolts for both channels. My high source resistor drop is under 350 millivolts, and My temp readings on the heatsink have been at 48 degrees C and under, which seems like a good place for them. So I'm pretty happy with where it is. I ran the left channel up to 20 volts undistorted output, RMS, and I'll need to check the right channel. Okay, the unit is buttoned up, and I'm now going to do some output tests on the right channel. So let's see, we'll crank this down. We're at the, what is that, 5 volt scale? Wish we could zoom in on that, but okay, we're at about a volt or so of output. So I'm going to bump the there, it moves a little quicker if I bump it up by tenths of a volt. So we're at 10 volt output now. You can see nice and clean on the right channel. There we're clipping at the top. Not yet. Okay. There it's clipping. Okay, so we'll back it off of clipping. And we're at 19.4. And it looks a little lumpy. So there's definitely see. So we're getting about 19 volts undistorted RMS out. And that's what I was wanting to see. Yikes, what's that? Oh, helps 5 output. Let's we're down in the noise floor. So not going to see much there. That's typical of most amps that I see. And a little bit of noise on it. I may feel safer or happier bypassing the input resistor with a capacitor. The 47K input resistor, I'll put like a 100 puff cap across it, which will hopefully send a lot of that ultrasonic nasties to ground rather than letting the amplifier amplify them. I know Mr. Pass talks about this being a wideband amplifier capable of about 800 kilohertz bandwidth, but my experience has been that usually means you're going to pick up all kinds of RF and other nasties. I mean, we just have too much. We live in a very RF noisy environment these days. I'd just rather not have the amplifier trying to amplify something I can't even hear. But it looks like we can do full output on both channels, so that's what I wanted to see. And so the next step will, I'll hook it up to my crappy little expendable speakers and let it play for a few days, see how it behaves. While I was testing the right channel, I was looking at a left channel offset, and you can see it's pretty low. So I feel this has been a pretty successful, knock on wood, project so far, and pretty happy. I think I need to put a damping plate, some Dynamat on the top cover, keep it from rattling. Yeah, I'm happy. I mean, for after all this time, it looks like it's going to be quite a success here. Of course, we won't know till we listen, will we? Anyway, that's it for Friday night. Hopefully we can, I'll come back with a listening to some music tomorrow. Hi, this is Robert, and as you can hear, it is playing. Finally, after a year of gathering together parts, hunting down parts, building up boards, waiting for match transistors to come in. Finally, I have a working functional Class A amplifier. That was a nice little Bach piece to welcome us in, hopefully non-copyrighted. But it is finally done and stable, sounding good. I've put my caps on the input, keep any external RF nasties out of the amp. I've also put some Dynamat under the top case, under the top cover here, help damp it out. Just a hint, what you'll find on these, if you tap on the top cover, the center here will bang against the back plate. So I've also put some pieces of electrical tape back here in the middle just to prevent that happening. But I am happy. It is hopefully done, and right now I'm going through it'll be going through a period here for the next few days of just playing discs on a loop and just giving it every chance to fail before I hook it up to the Magnepans. So I won't know really how it sounds until then. I'm hoping it sounds really good. We'll see. But anyway, thanks for putting up with all this. I appreciate all my subscribers who have been checking out my videos. And this should be a very long video going through all the bias process and this final bit. Anyway, again, thanks for watching. Have a great day. Bye.